continuación vamos a tener a Junior Developer Software Engineer. Nuestro ponente va a ser Kojo Idrissa. Ahora los voy a dejar con él.
Buenos días, everyone. Hello. I'm Kojo Idrissa. My name is on top of the slides, and my Twitter handle is at the other side. So this talk is a junior developer's guide to software engineering. The idea is to try to help people who are trying to make a career change into software engineering. So you saw a little bit about me, but then there's some other things that I do. I'm also one of the organizers for DjangoCon US. I am also, I work with DEFNA, the Django Events Foundation North America. I function as the North American ambassador. So I travel around North America, coming to events like this. If you want to know about what DEFNA does, you can find the Twitter handle there at DEFNATO. So in this talk, we're looking at people who are learning to code, but there are different reasons that people might learn to code. So why are you learning to code, and how do you want to learn to code? I'm focusing on two different styles of coding. One that is more useful for people who are trying to get hired as software engineers, and another that might be more useful for people who are just learning to code for their own purposes. So, primeira problema, if you're trying to change careers and get hired as a software developer, most people who want to do that, they want to start out and find some sort of a junior developer job. The problem is no one knows what a junior developer is, so how do you know when you're ready? How do you know if you're prepared enough? And so, in much the same way that if you are trying to become, say, you're trying to change a certain profession and you want to know if you're ready or not, in programming, people often take the approach of trying to learn more of the programming language. But just like if you were trying to become, say, a journalist or something, learning more words doesn't prepare you to become a journalist. So there are other things that you need to know. And it's the same with Python. So if you're increasing your vocabulary of Python, does it make you a better software engineer? And so people will often ask the question, how much Python do I need to know to become a software developer? And trying to learn more Python isn't always the best approach. There are other sets of skills that you need. Just like to become a journalist, you don't just need much vocabulary. There are other things that you need to know. So this is the primary problem. The secondary issue is how do you mentor new developers? And so if you are looking to hire developers, new developers, what are the things those new developers need to know? And so this talk will cover some of those things. So here we have two different styles of programming that you focus on a lot. So programación, just programming on its own, or being a software engineer. The main questions here are, ¿quién es el autor and quién es el usuario? So who is actually writing the software, who's actually using the software? If you're programming, maybe the user of the software, or the software is being written by yourself, and the person who's using it is the author, the person who actually wrote the software. And as a result, the software doesn't need to be robust, since the user is also the one who wrote the software, so they can make changes. But if you are doing software engineering, the software is written in a group. It's not just one person, it's written in a group. And the people using the software are going to be other people other than the author. And as a result, that software needs to be more robust, because people who are using the software don't have a chance to change it. The people who are using the software aren't the people who wrote the software. And so this talk is going to focus more on software engineering than on individual programming. And so here I'm going to sort of make an interjection. Sometimes you will hear discussions about people being real programmers or not real programmers. And so if you write code that does what you want it to do, you're a programmer. The idea of doing one style or another doesn't make you a real programmer or not a real programmer. It just depends on what you need. So if you were doing, say, data science, maybe the programming style is more useful for you, because you're the one writing the code and you're the one running the code. But if you are trying to do software engineering, if you're trying to be hired by a company to make software products for other people, then you might need to use the other style. But if you write code that runs, you are a programmer. We hope to see you at the next meeting. Por favor, trae comida. You should come to the next programming meeting. And so, what are the things I'm going to talk about here? So here, we have the different topics of discussion. Version control is the first one I'll talk about. Documentation of the software is also important. Programming the software testing is very important, and it leads to a lot of other things. So we'll talk about that more. Also, managing your dependencies and deploying your software is important because as software gets more complicated, that's something that you need to be prepared to deal with. And then working with your software development environment. So if you're trying to become a software engineer, these are all skills that you need to have beyond just knowing more of the programming language, knowing more Python. These are other skills that are helpful. And you can start learning these skills from the beginning. So first, the sistema de control de versiones, ¿por qué? So why do you need this? First, it helps you protect yourself from mistakes. So when you're writing code, if you make a mistake, you can go back and you can go back to a state where your code was working. It also makes it easier for you to try new things, so you don't have to be afraid of trying a new thing and having to break your code. But then also, it's very important for learning to work in a team. So, as we saw before, most software engineering is done in teams, and so teams will use version control, and it helps people put their code together. I'll talk about that in a little more detail a little later. So, when do you want to start using version control? Once you get to a point where you have more code that you want to have to type over and over again, this is a good time to use version control. If you get to a point where you have code and you're worried that a change will break it, that's when you need version control. So you can make a change, and if it breaks, you can go back to something that works before. So then, how? How do you go about learning to use this sort of version control system? You can use it by yourself. It's probably one of the best ways. So if you're just coding on your own, you can use something like Git to use version control on your own, and it helps you practice making these small commits of code as you go along. Then you can also practice what's known as branching and merging your code, so bifurcating and dietica. So you can practice this on your own. So if you have code, you can escribe, then bifurcar, escribe, dietica. And so this is the process in which a lot of code is developed, but you can do this on your own. You don't have to be in a team, but this will help you practice so that when you are working with a team, that's how a lot of code gets done. And also, Git and GitHub are two separate things, so you can use Git on your own before you start working with other people using GitHub. And so, if you're new to version control and it's not familiar to you, and you want to know how do you go about getting better with it, there's a book, the ProGit book, that's available. It's available online and it's free. And the first 3 chapters will teach you most of what you need to know to use Git every day. About 80% of what you would do every day in Git. The first 3 chapters are going to cover that for you. So when you start looking at documentation, there's the question of why. Why do you need documentation? And here I'm talking about documentation inside the code as opposed to documentation about the code, how to run the code. And so documentation is helpful because it helps you refine your thinking. It helps you think more about the code that you're writing and why you're writing that code or why you're doing it in a certain way. And then as you go forward with your code, maybe you forget why you wrote this before. And so if you have documentation in your code, it can help you go back, and it can help remind you of why you made the choices that you made. And then if you're working in a group or in a team, you can point them to the documentation and they can understand, oh, well, why did you write this code this way? They can look at your documentation and see why you did this. So on this topic of documentation, you will hear people say maybe that good code is self-documenting. So if your code is good, then bueno código de autodocumentación. Sort of. Sometimes yes, sometimes no. The idea is code can be self-documenting if all the names are written very well and they're very clear to people, and the people who are reading the code also understand those names. But making good names is hard. It's not an easy thing to do. And so it's something that takes practice, but the sooner you start practicing it, the better you get. But the idea that good code is self-documenting is not really true. So it's something that you have to start working on and start practicing as early as you can. So when do you want to start adding documentation to your code? If you're using a new technique, then it's good to document that because it can remind you of why you made the choices that you made. You know, why did I decide to use a dictionary instead of a list? Why did I decide to use this function instead of that function? Also, when you're writing functions in your code, once you get to a point where you're writing functions in your code, it's good to document that because it can become unclear very quickly once you're writing functions. And so again, this is looking at it from the standpoint of someone who is new to programming. So you don't have to be an advanced developer to start adding documentation to your code. You can start to do this very early. And so again, talking about that how, what are some of the ways that you can actually document your code? I would say adding doc strings to your function is sort of the minimum thing that you need to do. And so you want to answer 3 questions. 1, what does the function do? 2, what is necessary for the function? What does the function take in? And then what data types does it take in? And then 3, what does the function give back, including those data types? Because this can help you as far as debugging problems. If something isn't working, you know, am I giving the function the wrong thing, or is the function giving me back the wrong thing? What is this function supposed to be doing? And so these are some of the ways some of the fundamental ways you can get started in documenting your code. And so the next thing we're talking about is tests. And so why do you need tests? And so there are lots and lots of reasons. I'm going to give an overview of that. So, ¿por qué pruebas? Panorama. So when we talk about test pruebas, we're really talking about pruebas automatizadas, so automated tests. And with automated tests, you want tests that you can run in an automated fashion, and then from automated tests you can get to CI, continuous integration. And so we talked before about microcar and reintegrar. And so this reintegrar process, this is the integration. And so what you want is continuous integration. So every time someone adds new code, every time there's an integrar, you want your tests to run to make sure that the new code that's being added is correct. But you can't do that if you don't have automated tests. You can't have automated tests unless you have tests. And so once you have continuous integration, you have continuous delivery, which means once you've integrated the new code, you've taken the code that's branch and merged it back in, you know that it passed, so that code is ready to be shipped out. And then after that, you can have continuous deployment, so that every time you add new code, that code can be pushed out to whoever is going to go use it. But all of those things can't happen without tests. So no pruebas, no automated pruebas. No automated pruebas, no CI. Yes, yes, yes. So you have to start with tests first, and then that can lead you to these other things. So this is sort of the larger picture, and this is the goal for many software engineering companies, is to have this continuous deployment at the bottom. But you can't get to that without the first steps. So as a new software engineer, learning about writing tests is important because it will lead you to these other items. So, why are you writing tests as a new developer, as a new programmer? Why do you want to write tests? Again, it helps to protect you from future changes, breaking your current code. And so we've got different types of tests. One type of test is called a unit test, where you just look at one small piece of code and test to make sure that works. But then there's another type of test called a regression test, where you have code that was working, and then you find a bug, and you go back and fix it. And so that makes sure you make sure that that bug doesn't come up again. And so as you go forward, you've got these tests that are sort of keeping things in place. And so this assurance that past fixes still work, your regression tests help cover that for you. And then also it helps to develop good habits for teamwork. So we talked before about code being written in teams. So if I'm working with people and they're adding code and I'm adding code and other people are adding code, if there are tests there, then we all know that the code works well together. If you don't have tests, then there are no assurances that the code will all work together. And so when do you start writing tests? Ahora. Mañana? No. Ahora. Right, start writing tests now. Writing tests, it is both art and science. And so you want to begin practicing as soon as possible. It takes time to figure out how much to test, how much not to test. So you want to start writing tests as soon as possible. You get better with it over time. And so how do you go about writing tests? In Python, there are two things, dot test and unit test. They are built into the language. You can use both of those to start writing tests now, just to begin getting practice. There's something called PyTest, which is an external library that is very popular now for running tests. And it's one of the things that lots of people use. But you can start with just dot test and unit test. Those are already built into the language. So if you have Python, you already have testing facilities there. So now we get into dependency management and deployment. These are related but separate. So dependency management, as you build software that gets larger and more complex, it has more pieces that it relies on. And so you want to make sure that all the pieces that your software relies on are there and available with your software. So if you're, say, building a project in Django, maybe there are some other libraries that you need that add functionality. So you want to make sure all those are available. And so dependency management is part of that. But then deployment is a process where you need to, if you're writing software for other people, it's not going to just run on your computer. So you need to be able to put that software someplace where other people can use it, or you need to be able to give it to other people. And so you need to combine these two with dependency management. So if you give software to other people, but it doesn't have the pieces it needs to work, then that's not helpful. And so these are two related things that are important to look at. And so you may have seen some of these terms before. Virtual environments, they deal with the first issue with dependency management. You create a virtual environment to make sure that all the dependencies you need, all the different pieces you need for your software are available. Containers do the same thing, but the containers are also useful for deployment. And so if you have your software designed to work in a container, you can put all the dependencies in that container, but then it's easy to also give that container to someone else or to send it somewhere so that someone else can just run that container and know that the dependencies are in it. A virtual machine is similar to a container, but it's a little larger. It has more detail in it. But containers, the second one, is probably the more popular option right now. It's something that more and more people are using in their software development.
But, sorry, it's the best choice that we can use?
Containers, are they the best choice?
Instead of virtual machine?
I think it sort of depends. I think it is definitely becoming more popular.
Yeah, but I mean, it's popular, but it's really good.
It's one of those things that varies from situation to situation. So the advantage of a container is that it's smaller and has less overhead. Whereas there are a lot of situations where you don't need the extra overhead of a virtual machine. A virtual machine is trying to make a copy of an actual physical computer, and you don't always need that. Sometimes you just need the core software. So saying which is better than the other, it's hard to say. It varies from situation to situation. But I mean, virtual machines have been around longer, and if you are trying to, it's useful to be familiar with both. But if you are trying to sort of stay current with current trends in software engineering, containers are definitely the thing to look at. But I've seen mixing and matching. So I know some places where they will use a virtual machine to then run containers inside that virtual machine. It's a thing. If people in front of me make you face it, what the? I don't know. But people do it, and I've seen it done. So sometimes you might use both. So other things I want to talk about, being familiar with your software development environment. So again, this is from the perspective of looking at new people who are trying to become new software engineers. So beyond just knowing your programming language, just knowing Python, what is the development what is the environment you'll be using to develop software? And so, are you familiar with the CLI, the command line interface, or do you just point and click with things? Depending on where you work or where you want to go to work, one of those might be used more than the other. The CLI, the command line, is more common in a lot of development situations, but there are some places where you might use a GUI more frequently. So how well can you navigate those environments? Second, the terminal multiplexer is something that's useful, especially if you're doing like web development. So maybe you're building a web server, you're building an application, say like something like Django or another web framework, and after you've written your code, you want to run it to test it. So when you run it, that will take over your screen. You can't do anything. And so a terminal multiplexer will help you create sort of another copy without having to make a new tab. And so you can still work on your code while that web server process is running. So that's important to know. Also, some sort of a shell language, like a Bash, which is going to be most common on Unix machines or on a Mac, or PowerShell if you're developing in a Windows environment. Either of those is very helpful. So, when we look here at the end, these are the topics that I'm talking about. And again, if you are looking to become a software engineer, there's often a temptation to just try to learn more of the language, like more Python, more Python, more Python. And that is helpful, but if you are looking to work as a software engineer, even from the beginning of your journey, if you focus on these areas and become familiar with them, you'll be in a much better position to find a software engineering job or to work in a software engineering team. Because again, most software is built in teams. Most commercial software is built in teams, or open source software. It's not built by one person by themselves. It's built in teams, and these are the different tools that they use. And you as an individual can start using these tools yourself as you go along the journey. One other issue I want to talk about is trying to find new developers or trying to hire new developers. And so if you're an engineering manager or a developer lead or someone who wants to hire other developers, often people will look for a senior developer, a more experienced developer. The problem is, an experienced developer wants a lot of money because they are experienced and they're in demand. And so it's hard to find them. However, if you can find newer developers, there are more of them. And you can bring them in and you can help them learn the things that they need to learn to be a productive member of your team. But then the question is, well, what does my new developer need to know? And so that's where this becomes helpful. So regardless of how much Python or how much programming language that person knows, you want a new developer to be familiar with these things. And if you have some sort of a guideline like this, it makes it easier for you to find new developers and bring them onto your team and help them to be productive members of your team. So this is the end of what I've got. This is my Twitter handle if you have questions or want to reach out to me. My website is here, and then the slides are going to be, they're not there yet, but they'll be at that URL on that repo on GitHub. And I think there's also a PythonDay México repo, and I'll make sure that the slides are there as well. Thank you for your time. If there are any questions, I'll do my best to answer them. I'm sorry for my limited Spanish, but.
Can you show, well, I want to take a picture about continuous integration, continuous Yeah, that one.
One of the reasons I included this slide is because I think I've noticed a lot of people, you hear about software testing and it's like, oh, write tests because it's good. Well, yes, but there are, I think seeing the larger picture of where it can lead is important. If you have tests, this continuous deployment is really what not a lot of companies actually do, but it's the goal for a lot of companies. So imagine a situation where every time someone writes code and then they push that code, it kicks off a chain where the tests run and then the code is working and then boom, a new version of your software is live and running. But it's because you've gone through, you have all these things. You have tests and they're automated and they can be run automatically, that sort of thing. And so this is what a lot of companies want to do. And again, if you are trying to change careers especially, and even if you are like a university student and you're studying computer science, it's still useful to know these things. But especially for someone who is trying to change careers, instead of just learning more of the programming language, just being familiar with this process, because this continuous deployment, if you are working in a software business, your business only makes money if they give software to you. It doesn't matter how much software you write. No one cares. There's no money for that. There's only money if you give me software that works. And so continuous deployment is important because every time I write software and I say send, git push, then boom, new software. So you give people new software, and they continue to give you money. And so this is sort of the goal from a business perspective. But without Kubernetes, there's nothing. So you have to start with that. And then as you're learning the programming, if you can start learning to write tests early on, then you can start contributing to the process. This is literally where the money comes from.
So what do the Python test? It is a kind of
PyTest?
Python.
So PyTest is it's a library that is used to run tests. It's popular because it makes it easier and simpler to write tests. The language that you use to write tests is simpler and not as complicated. And then there are a lot of other modules that are available for it that work with it, so that you can run your test. You can write your test more simply. So that's probably the key thing. But then there are other modules that are available for it that lets you, say, take the results from your tests and turn those into reports that are more useful and that are easier to read or that you can share and that kind of thing. So I don't really have an example, but if you look at, say, the unit test module that's built into Python, and then you look at some PyTest examples, you can see like the same test will be shorter and simpler and easier to read when it's written with PyTest as opposed to unit test.
Was practicing teamwork out there? How is that advantageous versus just opening a tab and
So, let's see. And that honestly sort of varies depending on who you talk to. So there's some people who are like, no new tabs, I don't want new tabs. But I tend to use Tmux. Well, so I actually use Screen, but Screen, Tmux, Yobu all sort of serve a similar purpose. You have, on the one hand, fewer machine resources that get used, but then also it's just a little sort of clearer instead of having multiple tabs to jump through. Because you're right, another approach is just to open another tab. I guess I started using this at the job where I am now, and I found it useful to just not. I tend to have a lot of tabs open already, and it's too many, and so something that lets me have fewer tabs open is nice, and it lets me sort of focus my work in that one area, and then I can switch between them with key commands. But yeah, I myself, I have been looking for sort of a better answer to that same question. So it's a newer thing for me, but I found it useful. Which is passing.
La Universidad de Guadalajara, a través del Centro de Ciencias Económicas, Administrativas y MX y Python Cabal, otorga la presente constancia a Kojo Idrissa por su participación como ponente en a Junior Developers Guide to Software Engineering en el PythonDay México 2018.